Chemistry Show.
My name is Anne.
And I'm Katie.
And today we're going to be talking about
Sublimation.
So what is this technique used for? Sublimation is the transition of state from a solid to a gas without passing through the liquid state. Sublimation refers to the physical changes of transition and not the chemical changes when the solid is converted to a gas. This technique is commonly used as a purification method of volatile solid from contaminated non-volatile impurities. Sublimation is used for many processes, such as freeze drying in a process called lyophilization, frost-free freezers, and dye sublimation like printing.
Okay, so how does sublimation work? Now look at this phase diagram, which is this graph right here. This phase diagram depicts the states of matter of solid, liquid, and gases for various pressures and volumes. The triple point in the middle of this diagram represents the minimum pressure for which the substance can be a liquid. Below that pressure point, the solid transitions into a gas phase when the temperature drops below the level of the solid phase. Sublimation occurs when a compound's vapor pressure equals its applied pressure. This is an endothermic process because the sublimation requires additional energy. Sublimation is caused by the absorption of heat. This heat provides energy for molecules to overcome the attractive forces of each other and escape into the vapor phase. Compounds that are most suitable for sublimation tend to be those with weaker intermolecular forces in the solid state, making an easier transition from a solid to a gas since they are not so tightly bonded. These are usually compounds with symmetrical or spherical structures. For example, iodine crystals and solidified carbon dioxide, such as dry ice, are examples of substances that sublimate at room temperature and regular atmospheric pressure.
So what is this technique used for? There are two ways to conduct this technique in the laboratory. The first technique is done under atmospheric pressure, and the second technique is done under reduced pressure. In the first technique, the dry solid that is to be sublimed is spread thinly on the bottom of a petri dish. It is important that the solid is dry. If it's wet, then condensation may form on the top of the dish during sublimation. Cover the bottom of the petri dish with the top of the dish and place it on top of a wire mesh on a hot plate under a fume hood. The wire mesh helps to dissipate the heat evenly to the dish. Then place a beaker filled with ice water on top of the petri dish. As time passes, the solid will sublime and collect on the upper petri dish. Make sure to watch for charring. Continue the sublimation process until little or no solid remains on the bottom of the dish. Carefully remove the petri dish from the hot plate as to not allow sublimated crystals to fall from on top of the dish. The crystals on top of the petri dish are purified and must be retained so their mass can be determined. This method usually has a 90% recovery.
So the second technique. The second technique is vacuum sublimation technique that lowers the pressure. So when the pressure is very low, a substance that usually melts into liquid liquid form will sublimate directly into vapor with the addition of the heat. Under this reduced pressure, the solid volatilizes and condenses as a purified compound on a cooled surface, leaving the non-volatile impurities behind. Start by placing the sample that is to be sublimed in the bottom of a sublimation apparatus. Use a thick wall tube to attach the vacuum arm and apply the vacuum. The cold finger is a piece of equipment that is used during this lab. This tool will be filled with water and ice. Make sure to apply the vacuum before cooling the finger to keep the water condensation from forming. Then wave a Bunsen burner on the apparatus to heat the sample. Sublimation should soon occur in a few short minutes. Solid will start to deposit on the cold finger. Coax the solid away from the outside of the glassware and toward the cold finger by waving the Bunsen burner on the sides of the glass. Once the sublimation process is complete, remove the coolant, which would either be a condenser or an ice water coolant, and allow the apparatus to cool down to room temperature. Carefully open the system, as an abrupt opening will cause air to knock the crystals off the cold finger and remove the cold finger. Scrape the crystals onto a watch glass and calculate the mass.
Well, thank you for tuning in to our show today on sublimation, and we will see you next time.